Walk saw the successful addition of a new science instrument known as COS, or Cosmic Origin Spectrograph. There was also complete success in an unprecedented on-orbit repair effort with the Advanced Camera for Surveys. Both COS and ACS have passed their aliveness test, and COS has also passed its functional test. A very pleased Mission Operations Manager, Keith Wallius, shared his thoughts on the day shortly after his team got off duty in the stock.
So today was the third EVA day, or third spacewalk day, and this was what we thought was going to be our most challenging day, especially with all the challenges of the last few days. We were really a little bit nervous. You know, the last few days, it's been emotional because everything's been getting done, but it's been tough. You know, we've had a problem with the rendezvous, the communication. We had a problem with the wide field, getting that camera out. We had a problem getting the gyros in. And these are things we've pretty much done before. So we thought, wow, these are going to be pretty easy. And here today, we have this amazingly challenging task. So we were all cautious. So then we started off with Cosmic Origin Spectrograph, took out the old CoStar, and it was kind of a momentous point because this was the original fix for the aberration. So even the astronaut, John Grunsfield, he mentioned it, and he said, wow, this is kind of historic, and he's right. So this went perfectly. They took it out, put in the new instrument without a hitch. We tested it, we did our aliveness test, everything worked perfectly. Right now, actually, we're in the middle of the functional test, making sure that all of the detailed functions of this work, but we know it has power, base functions work, now it's just playing with it and make sure it works right. Then the next was this Advanced Camera for Surveys, and this is complicated. Again, it's not just going in and taking out one and putting in another. They had to go in, they had to cut through a mesh grid, they had to go inside, they had to take out 4 different cards, put in a replacement for it. It's incredibly complicated. They had different tools to make this easier, but they made it look easy. We thought it was going to take a lot longer than it took. They actually got done in an hour less time than we expected. He was so far ahead. He was so well trained. He did such a fantastic job. It was just a feeling of euphoria in the control center when we got done.
Oh, it's on!
When you think of where we were just 3 days ago to where we are now, we have new batteries, we have new gyros, we have a new science handling computer, we have a new wide field camera, we have a new COS instrument, we have a fixed ACS camera. It's just amazing the different telescope you have now from 3 days ago. And we still have 2 more days to go. Tomorrow, another challenge. If you had asked me before the mission, I would have said the 2 hardest days we had were today and then tomorrow. Because once again, we have one of these instruments, a Space Telescope Imaging Spectrograph. This was installed back in 1997 on our second servicing mission. And it too had a problem a few years back, and it had a failure on it. So once again, we're going to repair. We've done this before this mission. And the other thing we need to do is put on this new outer blanket layer. The outside of the telescope, there's a MLI, this multi-layer insulation that's been there since launch, and that protects it from the harsh environment of space. Well, it doesn't do that great a job protecting it from the harsh environment of space over 19 years. So therefore, what we're going to do, we're going to go and put basically this new outer blanket layer. It's basically a big stainless steel cover on top of it. So we'll slap that on. We've done this in the past mission too. We've put them on in other missions and it's worked great. And then that's going to protect us for a long time for the future. So the 2 big tasks for tomorrow, repair a space telescope, imaging spectrograph, and put on this new outer blanket layer to give us that thermal protection for the future. It's still a pretty big day.
As Keith mentioned, the 4th spacewalk of the mission will involve another repair effort when the other pair of spacewalking astronauts, Mike Massimino and Mike Good, make their second venture into Atlantis' payload bay to repair the Space Telescope Imaging Spectrograph, also known as STIS.
In August of 2004, there was a 5-volt power supply that drives the mechanisms on STIS, and it failed. When that happened, it basically meant that STIS could not do science anymore.
STIS was our first black hole hunter. It confirmed for the first time the existence of a supermassive black hole in the center of a galaxy, and it went on to make the first detection and chemical analysis of the atmosphere of a planet around another star. We want to keep on doing that kind of work.
STIS is what's called a spectrograph. What it does is spreads the light out into its different wavelengths. That's really important if we want to learn about how fast an object is moving, what it's made of, what the pressure and temperature. It's getting at the physics of what's going on up there in the universe.
You might well ask, if we're going to fly a cosmic origin spectrograph that's the most sensitive spectrograph we've ever put on Hubble, why do we need to bother to repair the Space Telescope imaging spectrograph? Space Telescope imaging spectrograph can do a number of things that COS can't do, and conversely. Between the cosmic origin spectrograph that's very fast and very efficient, and the Space Telescope imaging spectrograph that provides finer resolution and a smoother cut, as it were, through the light from a star or a galaxy, and you have a much more complete set of tools to use for a variety of purposes.
There was huge motivation to recover STIS, so our engineers embarked on one of these rapid development programs, and the STIS failure was very easily characterized. We knew exactly what happened, we knew exactly what card, we knew exactly what component, and the challenge became, can we get to it?
This particular activity that we're going to do to try to fix STIS wasn't meant to be done in space, it was meant to be done here on Earth in a clean room.
Now, since no one ever expected this to happen, when they sealed up this instrument, they sealed it up so it was nice and secure. In fact, there's 110 of these very small screws that we need to remove from the instrument in order to gain access to the board we need to replace.
And these screws are not what we call captive. In other words, as you take the screw out, it's loose. There's nothing holding it to the board. The engineers here at Goddard have been very creative in designing a cover plate that we can put on over top, that as we take the screws out, they'll be captured by this plexiglass cover.
We designed what's called the fastener capture plate. It attaches onto the instrument. It's got holes that the astronauts can access their tool into. They're small enough for the tool bit, but not large enough so the fastener can come out.
My job is going to be to drive each one of these screws, remove that plate, get inside of it, and then remove a board, much like you would remove a board in a computer in your house, except we're in these fancy clothes, a big fancy spacesuit, and we're using fancy tools to do it. We want to make sure we do it right.
If we are going to go do exploration and continue with on-orbit assembly and test of spacecraft, we got to learn how to do that. We got to learn how to pull boards out and put boards in. And so here we are, Hubble once again is the Pathfinder.
The other planned activity during the fourth spacewalk is part of the effort of extending Hubble's operational life. In this case, it is the installation of new thermal protection material known as nobles, or new outer blanket layer.
We're going to install a new outer blanket layer called a noble, which is a solid. It's not a blanket anymore, it's a solid sheet.
We designed a new outer blanket layer that can either lay on top of the degraded blankets, just cover them up,
or we will take off the blanket in order to install a new radiator against the bay door.
And this is a very weather-resistant new outer blanket layer that we have designed, so it should not degrade appreciably for the next 15-20 years.
So at the end of this servicing mission, where we've installed new cameras and upgraded all of this infrastructure, the whole point of this is that the Hubble Space Telescope will be better than it's ever been in its history, and will continue to produce this breathtaking and amazing science well into the next decade.
With almost 22 hours of spacewalking time already under their belt, the STS-125 astronauts have already accomplished 5 of the top 6 mission science priorities. We will now return to Mission Control in Houston for continuing NASA television coverage of the flight of Atlantis on the STS-125 mission. Up next on NASA TV will be the next airing of the Flight Day 6 highlights video package.